Hey guys, so today we're going to look at 3 more rules, which will be power to a power and negative exponents and zero exponents. So you see this first one, we have z to the third to the fifth. What this means is that we have this z to the third 5 times, okay? So when I expand this out, I'm going to have z to the third times 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 z to the third. Okay, now if you remember our rules from yesterday, we do add those exponents. So we're going to have 3 plus 3 plus 3 plus 3 plus 3. And my final answer will be z to the 15th power. My next one, I have 2a to the 6th power, all raised to the 3rd power. Okay, so that means I'm going to have 2a to the 6th 3 times. So let's write that out. And we know from our product rule yesterday, we again add the exponents and multiply your coefficients. So I'm going to look at this as 2 times 2 times 2, which is 8. And I have 6 plus 6 plus 6, which is 18. So I have 8a to the 18th power. Okay. My next one, I have 4xy to the 4th to the 2nd power. So I have 4xy to the 4th twice. So I'm going to write that out. Again, we multiply our coefficients. So that's going to be 16. Okay. Make sure for the x, you don't forget that if it's not there or if it's not an exponent there, it's a 1. So I have to do 1 plus 1 and I get x to the 2nd power. Then I have 4 plus 4 and I get y to the 8th power. Okay, so looking at these 3, you should notice something from here to here, because what if they give us z to the 3rd raised to the 100th power? We don't want to sit there and draw 100 z to the 3rds. So you should notice something here, and I want you to take a few minutes and maybe pause the video and just think about what you notice. Okay, but what you should see, they are multiplying each time. So if I do z to the 3rd times 5, I get 15. Okay, here, since I have a coefficient, I'm actually saying z to the 3rd. So make sure you don't make that mistake and multiply that. This is 2 to the 3rd power. I have times 6 to the 3rd power. So 2 to the 3rd power is 8, and 6 times 3 is 18. Then here, I'm doing that same thing. So I have 4 to the 2nd power. Remember, x is to the 1st power times 2. Then I have y to the 4th power times 2. So 4 to the 2nd power, 4 times 4 is 16. I have 1 times 2 is 2. And I have 4, I have 1 times 2 is 2. And I have 4 times 2 is 8. Okay, so let's go to the bottom real quick so we can go ahead and write out that rule. So this is called a power to a power rule, meaning if I have it in this format where I have a term to a power raised to another power, that just means I'm going to multiply those exponents. Of course, a, m, and n are variables, so we don't know what they are. But once they put in numbers and variables in there, we just multiply the outside exponent with the inside exponent. Okay. All right. I'm going to go ahead and do our next rule because it's a little bit tricky. So yesterday we talked about negative exponents and we left them negative, but the rule is you can never leave a negative exponent in your answer. You're going to take the reciprocal and then simplify. So what's happening here is, like, let's say I have a term raised to a negative power. Okay, I'm just pretty much bringing that down and flipping it. So I'm like putting it over 1, just like if I had, let's say, the number 4 and I wanted to make it a fraction, that's 4 over 1. Okay, so I'm making this a fraction, and then since it's negative, it's going to come down. And when it comes down, that will remove the negative. It's kind of like magic, okay? So once it comes down or once you flip it, it is going to become negative, okay? So if you look at this one here, I have w to the negative fifth power. I cannot write out w negative 5 times. So we're not going to have an expand part for that. So what's going to happen is we're going to have that over 1. This is going to come down. So I have w to the fifth power. And that's it. Okay. Here I have x to the second power. Then I have divided by x to the sixth power. So we're still doing our quotient rule. So we're doing 2 minus 6, which gives us negative 4. But watch what happens when I expand this out. I have x times x times x times x times x. Okay, and we divided those. Okay. So remember, an x will divide out an x, and that will be 1. So these cancel out. That's 1. These cancel out. So how many am I left with at the bottom? Okay. I have 4 x's that are going to be multiplied. So this will be x to the fourth for my denominator. And since it's nothing here, that is a 1. Okay. So me changing this negative exponent, you can kind of look at it either way. If you want to expand it out and have it like this, that's fine. Or you may see it as, hey, well, I already know how to subtract. I just want to flip it over. Then that's that. Okay. All right, my next one, I have r to the fifth power divided by r to the fifth power. So I'm going to have r times r times r times r. And then the same thing at the bottom. And you'll notice something here too. This cancels out this. All these will cancel out. Okay, so anything divided by itself is 1. So my answer for this one is 1. A lot of people wanted to say 0, but this is division. If I was doing r minus r, then that would be 0. But I'm dividing r divided by r, so that's 1. Then when you think about it using the quotient rule, I'm doing r to the fifth minus 5, which gives me r to the 0 power. Okay. So here's another rule where you have something to the 0 power, and that will automatically give you 1. Okay. So once you divide this out, you'll see that you have r to the 0 power, and your final answer will be 1. So let's write that at the bottom, because this is our last rule, and it says any expression raised to the 0 power is 1. Okay, and this is how that formula looks. And yeah, let's go ahead and finish the rest. So here I have 8 times x times x times x. And I have 2 times x times x times x. Okay, remember we still divide our coefficients. So we have 8 divided by 2, and we get 4. And then all these cancel out. So that's just going to be 1. 1 times 4 is still 4. Now, if you use the rule, you're looking at this as 8 divided by 2. Then you have times x to the third minus 3. So you'll have 4x to the 0 power. But remember, we said anything to the 0 power is 1. So that pretty much cancels out. So it's like looking at 4 times 1, which is 4. And here, this one looks fun, but like we just said, anything to the 0 power is going to be 1. So our final answer for that one is 1, because all this to the 0 power, it doesn't even really matter what's on the inside. Okay, we just did that to confuse you a little bit. Okay, so anything to the 0 power will be 1.